Objective 4. When you have an equation that has exponents that have a variable, your first instinct is to look at them and decide, is there a common base or not? When you look at this equation, 9 and 43, you could do a prime factorization on this to see if there is a common base, or you can play around with numbers on your calculator to find a common base. When you do that, you find that 3 is actually a common base. 9 can be rewritten as 3 to the second power, and 243 can be rewritten as 3 to the fifth power. I rewrote 9 as 3 squared, so the rest of the exponent needs to go inside of parentheses. 243 can be rewritten as 3 to the fifth. The rest of the exponent goes inside of parentheses. Then I can distribute and ditch the base. So I have 6x plus 8 equals 5x plus 10. Now I'm just going to solve using my Algebra 1 skills. Subtract 5x from both sides. Subtract 8 from both sides. And I get that x is equal to 2. If you look at the second problem I have here, you may try to find a common base. But you actually can't find a common base for this. And actually, I just realized I wrote the problem a little bit wrong. It doesn't change the fact that we need a common base. But that minus 2 is actually supposed to be part of an exponent. So you may try to find a common base with this, but if it looks like maybe 3 might work. But 3 to the first power is 3, but 3 to the second is not 6. Therefore, you have to use logs in order to solve this. You can change this to logs by using your loop. Your loop always starts at the base, goes straight around the equal sign, and ends at the number next to it. So I have log with a base of 3 of 6 to the n minus 2 equals n. When you rewrite it like this whole part here has to go in front according to the power property. So I have n minus 2 directly in front. Log base 3 of 6 equals n. Now I can use change of base. Log of the attic number over log of the basement number. Now remember, I'm going to put this log of 6 over log of 3 into my calculator, and that's standing for a number. It's not a nice number, but it is a number. And I get 1.630929. And that number has to be distributed to both the n and to the negative 2. So I'm going to get 1.6309 n minus, and multiply that number by negative 2. So I get 3.2619 equals n. Now I need to get my n's on the same side. Now you've kept both of these numbers ideally into your calculator because you don't want to have a rounding error. We try not to use rounded numbers for our calculations. So in my calculator, I'm going to do 1 minus, and this number up here. Now, we talked about how to store this number, or if you need to, you can just retype the log of 6 divided by log of 3. but I get negative 0.6309, I'll say 3n equals negative 3.2619. And now we have to divide. If you're worried about being able to call up these numbers, you can always just write the entire number you see on your calculator and retype that in to make sure that you're not going to get a rounding error. So we have 3.26 divided by, so my answer is n is equal to negative 5.1699.